Relations and functions. As you know, all the functions are relations, but all relations are not functions. The question here is, the following relations are not functions. How can you restrict them to be functions? So there is always a way to make a relation as a function, right? So we may have to restrict few parameters so that we can make a relation a function. That is kind of important technique. So with the help of this example, we'll learn the technique of restricting relations and making them functions, right? We have two relations here. The first one is x squared plus y squared equals to 5, which represents a circle with radius of square root of 5, not 5. And b is inverse of y equals to x minus 2 whole square plus 3, right? So these are the two relations, and these are not definitely functions. The reason is, let's sketch them and then we'll figure out why they are not functions, right? So this one is, as I said, a circle. So let me draw a dotted circle here first. So this is a circle, and what is the radius of the circle? It is minus square root of 5, or plus square root of 5 is the x-intercept. Radius is always positive. Radius is positive square root of 5. Okay. Now x and y intercepts, I have labeled them here. As you can see, it fails the vertical line test. So if I draw a vertical line, it intersects the relation at 2 points. That means for a particular value of x, we have two different values of y, and we don't know which one we are talking about, and therefore this remains as a relation, but it's not a function. Now the idea is how to restrict it so that we can make it a function. Think about it, right? Now let me discuss the other part also, give you some time to think. Now here we have inverse of y equals to x minus 2 whole square plus 3. Now let's find the inverse of this. Instead of sketching this time, we'll find inverse of this, and I'll use that technique of reading the statement in the reverse order to get the inverse, right? That's a neat technique and very effective. So what I'll do is, the technique is read in reverse order. So the order here is x minus 2 whole square plus 3. Now the reverse should be, we have to take away 3 and then do square root with plus and minus sign and then add 2. Do you see that? Right? So that is the technique, right? So the inverse here is, let me write for the time being inverse. I'm not writing x here. Now, so from x, I will take away 3, right? And then do square root with plus and minus sign and then add 2. That is reading in the reverse order. When you read your equation in the reverse order, you actually get inverse of that function, right? So that's a very good way of finding inverse. So that's what we have. Now this clearly is not a function, since for any value of x we have plus and minus, so two values, right? So it's not a function. Now how do you make them function? That is the question. So normally we'll have, in fact I should say, there are two techniques, just two techniques which are always used. First one is restriction on range. In this case we can restrict range, right? So restrict range. And the other one is restrict, you understand what? Yes, you guessed it, domain. Perfect. Restrict domain, right? So if you could restrict domain or range, you can actually make a relation a function, right? So in this case, what type of restriction you think should be applied? Now here the restriction is, let's restrict range as y greater than or equal to 0. So if we only consider the y values to be greater than or equal to 0, that means we are considering the upper half of the circle. Now if you consider only the upper half of the circle, it passes the vertical line test, since that lower half is not being considered, right? So this particular restriction ensures that the relation becomes a function. So what we have now here is x squared plus y squared equals to 5, where y is greater than equal to 0, right? So that is how you can restrict relation and make it a function. Now in this particular case, how do you do it? What is the point which we should consider? The point is a vertex, right? If I consider the domain as, now here, as x greater than, the vertex is at 2, 3, right? Now if I say we are considering only the values which are x greater than equal to 2, in that case we are only considering the positive half of this inverse, right? In that case, f inverse becomes plus square root of x minus 3 plus 2, right? Do you get it? So that ensures that our relation is a function. So that is how we can really do it, right? So I'd like you to sketch the inverse of this function, right? So we have this function here, which is x minus 2 plus 3. That means a parabola kind of, let me just draw like this, right? X minus 2, so this point is at 2, right? Now add 2, the value is 3, right? So if you really draw the inverse of this function, then it will be, so at 2 it is 3, so the vertex which is at 2, 3, now for inverse it will be at 3, 2, right? 3 and 2, kind of here. So your function which we are talking about is kind of, that is going to be, okay. So if I restrict x greater than equal to 2, then I'm actually considering only this half of parabola. Do you understand? Only this half. And this half, the inverse of that is this portion, the upper half of the square root function, right? Which is clearly a function, right? I hope that helps you to understand, okay? So remember that we can always restrict relations so that they can become functions. With the help of these two examples, we saw how range can be restricted to make relation as a function, and also domain can be restricted to make the function as, or rather the relation as a function. I hope you appreciate it. Thank you.